All right, guys, 2-5 in advanced geometry, little area, perimeter slash circumference, and geometric probability. Start up top here with some basic formulas for our polygons and other shapes. Formula for area of a square will be the side length squared. Area of a rectangle, length times width. Area of a triangle, 1/2 base times height, and area of a circle will be pi r squared. So they want us to find the perimeter and circumference of the area of each polygon. It's all about work shown in this situation. So first off, we've got ourselves a triangle. Now what I want you to realize is the solid part, this is the actual triangle. But you see this dashed part right here? That is like imaginary information that is just going to help us with things. So first for the perimeter, or the circumference. Circumference is for circles, perimeter is for any other kind of polygon. So all we do is just add the side lengths up. Now that's a 2.5 plus 3.5 plus 3, which you could probably do in our head, but just showing you. And I showed no work on that. Perimeter, we are way too smart, in my opinion, to have to show work. That's going to be 9, and then we've got to get the correct label. That's going to be centimeters in this situation. It's either going to be centimeters, centimeters squared, or centimeters cubed. Well, it depends on what dimension we're talking about, and perimeter is just a length, which only has one dimension, so that's why the label on that is centimeters to the first power. Area, though, that's where we're going to show some work. So the first thing you do is you write down the formula for the area of the shape you're dealing with. Area equals 1/2 base times height, because we've got a triangle. And notice I didn't just write this part, the 1/2 base times height. I wrote the entire A equals. That's going to be important. So we will sub in the information that we know. I do not know the area, so A comes down, and then I've got a 1/2 there still. The base and the height, that's the interesting part. The base and the height have to be perpendicular to each other. So the truth is, any of these three sides could actually be the base of this triangle. It doesn't have to be the bottom, like you were probably taught in middle school. But the base and the height are perpendicular to each other. So do you see how these segments right here, even though this one's imaginary, are perpendicular thanks to this right angle box right here? So one of those guys is the base and one of those guys is the height. What I'll do is I will call the base 3.5 and the height 2 in that situation, and then I could just multiply these together. So real simple, the 1/2 and the 2 actually kind of cancel each other out, and the area is just plain old 3.5. Since they use decimals, we can use decimals in this problem. So the area is 3.5, and the label is going to be centimeters squared because area has two dimensions with it. It's got some length and some width. I mean, sometimes they're called a base and a height, but that's what centimeters squared is all about. And then centimeters cubed is for volume because there's length, width, and height in that. So moral of the story, got to write the formula down first, substitute in, then go ahead and simplify, and then we'll put our answer in the blank with a label. So realize what shape we got here. This is a quadrilateral, but it has 4 right angles and 4 equal sides thanks to our tick marks. So that is by definition a square. We'll learn more about that in chapter 6. But the tick marks mean all the sides are the same. So if this is 14, then they're all 14. So to find the perimeter, I could do 14 plus 14 plus 14 plus 14 plus 14, or just realize that's what multiplication is all about, and just multiply those together, or excuse me, multiply by 4, and then realize that the perimeter is going to be 56 yards to the first power because we're only dealing with length. Then area is, of course, side squared for this square. Instead of doing length times width, that's why we're doing side squared, because the length and the width are the same thing. So the area will equal 14 squared, which hopefully you know your first 15 perfect squares. That's a big old juicy 196. And the label will be square yards. Some people say yards squared, some people say square yards. It's all the same thing. So formula, sub, simplify, label. All right, next guy is a circle. So the perimeter of the circle, there is no such thing as the perimeter of the circle. So we're going to show work on both perimeter and area. There is no perimeter of the circle, though. It's called circumference. So the circumference of a circle is either going to be 2 pi r or it's going to be circumference is diameter times pi. It just depends on what given information you have. They are the same thing. The diameter, if you remember, is twice the radius in that situation. So these are actually equivalent things. Since they give me the radius, this will be the formula that I'm going to roll with. So I'm going to just get rid of this guy because I don't need him. Make my eraser a little bigger. And substitute in. Circumference is going to equal 2 times pi times the radius, which is 4. And we're going to call that 8 pi. What we do is we just keep this exact as possible. This is the exact answer. So the 2 times the 4 turned out to be 8, and pi comes along with the ride. So the circumference, which we could probably scratch that out and call that a C, is 8 pi. And I like to also approximate that so we kind of realize how much pi is. Remember, pi is about 3.14, but that's old elementary school, I should say middle school technology. We are going to actually take it times pi. So to take it times pi, the pi key, if you remember, is right here on my calculator. If you're not sure where your pi key is, let me know and I can help you with that. But pi, it's a second function, so I'm going to hit second and do that guy. And boom. We will round that to the nearest tenth, so we're going to call that about 25.1. And the label is going to be inches. You don't need to put the label on both of these. We're just saying, hey, the circumference is 8 pi exactly, and that's about 25.1 inches. Area, we always write the formula down for area. That's going to be pi r squared. And area, we're smart. This is advanced geometry, so I'm going to let us skip a little bit of step. We got to take the radius in here, which is 4, and square it. So we know that's going to be 16. And we don't write pi 16. Like pi doesn't come first. Pi always comes last. It's kind of like dessert when you're eating. You know, dessert always comes last. Always save the pi for last. So no pi 16. It's 16 pi. And again, we'll approximate that. So 16 times pi rounded to the nearest tenth is about 50.3. That's what approximate symbols are. 50.3 square inches because this is an area. And this bad boy right here is a rectangle. Notice it's got 4 right angles for this quadrilateral, but the sides are not the same, so it's not a square. So what we probably remember from back in middle school is that opposite sides of a rectangle are equal. So if that's 13, then this is 13 feet. If that's 8 feet, then this is 8 feet. And the perimeter, it's just time to add them up. There is a formula, 8 plus 13 plus 8 plus 13. But quite honestly, we are going to have so many formulas this year. It's like when it comes to perimeter, all you got to do is just add those things up. So it's 42 feet. I'm not concerned that it's like, well, it's 2 times this plus 2 times this. I don't care. But area, I do want you to write the formulas down. Remember, L's are supposed to be cursive, so area is length times width. Which one's the length, which one's the width? It doesn't really matter. So 8 times 13, getting ourselves a nice 104. Area equals 104. So 104 square feet. Sorry that my pen dragged right there. Cool. Again, another triangle in this situation. To find the perimeter, whoa, bro, we need to know all 3 sides, and I only know 2 sides. But it is a beautiful thing here that we've got ourselves a right triangle in that situation, and a little juicy dude called the Pythagorean theorem says if you know 2 sides of a right triangle, you can always find the 3rd side. You may remember the Pythagorean theorem. A lot of people call it a squared plus b squared equals c squared. Well, it does matter who's who. See, a and b are the 2 legs. That's these guys. C is the hypotenuse. And how do you know where the hypotenuse is? Well, the hypotenuse is always the guy right across from the right angle. So what we do is we take the 2 sides that we know, the legs, and we're going to do 5 squared plus 12 squared, and that should equal c squared in this situation. Then we can do the order of operations and do these exponents. So 5 squared is 25 plus a 144. That'll equal c squared. Then add those together. 25 plus a 144 is 169. Ooh, I like 169. Isn't that a perfect square? Because now that we got c squared all by himself equal in just one old term right here, we can get rid of the square by square rooting, and the square root of 169 is actually plus or minus 13. But the weird part is this is not algebra. You know, in algebra, this is the answers we'd have because they want to know what number squared would give you 169. Well, it's either 13 times 13 or negative 13 times negative 13. But since this is geometry and we're trying to find the length of a side, there is no way that there's no way that we're going to have a negative side length. So we totally only use the positive value. That negative is called an extraneous answer. So then I'm going to go put that in my picture if I'd actually grab a pen here. And now I can find the perimeter real easy. 5 plus 12, 17, plus another 13 is 30 meters. And the area, we actually had enough information to find the area because it's area equals 1/2 base times height. So the base and the height, remember, are always perpendicular to each other. So one of these guys is the base and one of these guys is the height. But since this right angle is right here, you know they're perpendicular to each other. So it doesn't matter who's who. One of them's the base and one of them's the height. So 1/2 times 5, notice I like to use parentheses, times 12. I could actually do this in my head because I got to take half of one of these numbers. It's half of 12 is really 6, so you got 6 times 5 in that situation, which is 30. So the area is 30 square meters. Now it just so happened that, that we got the same area and perimeter. That doesn't always happen. But we needed to do the Pythagorean theorem to find this missing side. And the only time you can do that is when you have a right triangle. And remember, the hypotenuse is the dude that goes all by himself on one side of the equal sign. If you were missing a leg, then you'd have to leave that one of those legs positions blanks. And finally, the last one of these simple guys is perimeter and area. Here we've got ourselves a beautiful isosceles triangle. You see that with the tick marks. So to find the perimeter, we're in good shape. If this is the square root of 305, then so is this. It's the square root of 305. That's what the tick marks mean. Now, a bad thing to do is to like punch in the square root of 305 and try to approximate that. We're going to keep things exact. So we need to add these three bad boys together. I need to add this 14, this square root of 305, and this other square root of 305. And we probably haven't added radicals together too often. Well, the way I like to teach it is you treat a radical like it's a variable. So just for fun right here, if we had 14 x and x, and I asked you to like add these two sides together here, I hope you realize that 1x plus one more x, isn't that really 2x in that situation? And of course, you'd have to add that other side. Sorry, I wrote that wrong. You'd add these together and you have 2x plus 14 is like the total perimeter. And you can't add those two together because they're not like terms. This guy's got an x with it, this guy doesn't. Well, it's the same concept here. You've got, let me get rid of this. You've got a square root of 305 plus another square root of 305 plus 14 is what you're trying to add together. And these square roots of 305, they're like terms. It's very similar to x plus 14. You totally just add the coefficients in front of them together. If you had 1x plus 1x, you got 2x out of that situation. Well, 1 square root of 305 plus 1 more square root of 305 is totally 2 square roots of 305. You don't add these numbers underneath the radical together. You just add the coefficients of those radicals. So the perimeter of this guy exactly is 2 square roots of 305 plus 14. And I like to keep that in parentheses to realize, hey, there's an entire group right there. So you can add those together. Now you can't add these together, like square root of 2 plus square root of 3. Like they're not like terms. That's like x plus y. You can't add those together. The only thing you can add together is the same radicals, like terms. So like the square root of 5 plus 2 more square roots of 5. See how they're both like square roots of 5? You can add those together, and that's actually 3 square roots of 5 because you got, sorry, because you got one of them right here and you got two of them right here together. That's a total of 3 square roots of 5. So new stuff right there, adding the radicals. You just kind of treat them like it's a variable. So you didn't need to show me any work on that at all. Like I said, it's a perimeter. The only time you're showing work on perimeters when it's actually a circumference, when it's a circle. But area we do. Area, this is a triangle. That's going to be 1/2 base times height. So to sub in, remember our base and our height, they have to be perpendicular to each other. So here's two dudes right here that are perpendicular to each other. This 16 is our height and this 14 is our base. So the area will equal 1/2 times 16 times 14. And what I'm going to just punch in my calculator is 8 times 14. Like I can do that mentally, but 8 times 14 right there is a juicy 112. Boy, I said juicy a lot today. 112. So 112 meters squared. And if you realize that I didn't even put a label up here because I got sidetracked, I totally didn't even finish this guy up here. So what I wanted to do was actually approximate that also. So 2 times the square root of 305, like you totally approximate when you're all done square root of 305. Make sure you get out of that radical if you've got a calculator like mine. Sometimes you have to close the parenthesis off if you've got another. So make sure that whatever's underneath that radical is only a 305, but plus 14. And rounding that to the nearest tenth, remember to round to the nearest tenth, we totally look at the number to the right of that one spot over, and if he's 5 or larger, we'll round this up. If he's less, we'll keep it the same. So that's approximately 48.9 meters. So my bad on totally forgetting to finish that problem right there. All right. Find the perimeter and area of the shaded region at the figure at the right. So you can see we've got some general shapes here. I've got this big old overall shape right here, this pink guy. I've got a big rectangle, which is 10 by 15. How do I know that that's 15 as opposed to just this guy right here being 15? Well, notice where the 15 is. The 15 is like in the middle of this orange segment right here. So where they located it. If they'd put that 15, let's just say like right here instead, where it's like in the middle of that pink segment, they're saying that that's only 15. So very tricky stuff here in geometry also. But the overall giant rectangle is 10 by 15. Sorry, I grabbed the wrong tool. 10 by 15. Well, the problem is that's not the entire shape. They've got this little dude right in here that's a square, because if this is a right angle and we've got our parallel lines and all of this stuff, that we just pretty much got to assume. We can prove it later, but we don't have enough information right now in this class to prove that that's really a square. But 5 by 5, this is a square on the inside. There's lots of ways to find like the perimeter and the area of this. So let's just start with the perimeter first off. Okay, since the big outside shape is a rectangle and this is 15, you know that this guy up here is also 15 because opposite sides of a rectangle are equal. And if this is 10, this entire distance is 10 also. But we only want the perimeter of the shaded region. So this dude right here is 5. And since the entire thing is 10 in that situation, and this is a square, you know this is 5, and this has got to be 5 also. So now we can add these up. And what I like to do, oh, sorry, I guess we need to figure out this little distance also. Remember, the whole thing here is 15, and this much is 5. So isn't this snug little dude right here going to be 10? But to add these up now, I like to definitely use my calculator, but I like to circle the guy that I started with and just go around the clock in that situation, so I don't like add things up more than once or miss a guy. So I need a 15 plus a 10 plus another 10 plus I need this 5 right here plus this 5 right here plus this 5 right here. So I'll grab it with the highlighter and just show you what I all added up. I started with this 15, then I did that 10, then this 10, then this 5, 5, and 5, and just the total of all of that is 50. And they do not give me a label, so we will put units, which we abbreviate UN. If you saw a previous teacher use just U for units, I don't like that, so UN. Now the area of the shaded region, though, there's quite a few ways we could do it. We could section this thing off into shapes we know how to find the area of. We could take the big guy minus the little guy, and that's what I really like to do. What I like to do is find the area of the big shape and take away this little guy right here. So we're going to do area, so we need a formula. But since we're going to do more than one area, because we got a big shape and a little shape, we're going to do area of the big as a little subscript. That's going to be length times width. And I'm going to go ahead and find that. So a sub b, like I don't have to write big every time. The length of it is 15 and the width of it is 10. So the area of the big is totally 150. Then, since I want to find the area of the little guy, so I'll do area of the little. That's a square, so side squared. Area of the little is 5 squared, which is 25. And to find the area of the shaded now, don't we need to take the area of the big guy and take away the area of the little guy? So the area of the shaded would be 150 minus 25, which is 125 units squared in that situation. So like I said, we could have sectioned it off also and found the area of this shape and the area of this shape and added those together. There's more than one way to do it, and I don't care which way you do it, as long as we show our work and see what we're doing. So writing formulas down first, that's the big key. That'll pay off in dividends later. Find the perimeter and area of this guy. So perimeter, it's a rectangle, it's a quadrilateral with 4 right angles. So if this is 3 radical 3, this is 3 radical 3. This is 8 radical 2, so this is 8 radical 2. And now I got to add these together. And remember, this is back to those add and radical stuff again. You can only add like terms. So you can add radical 3's with radical 3's, and you can add radical 2's with radical 2's. So here's 8 radical 2's, and here's 8 more radical 2's. When you add those together, don't you totally get 16 radical 2's in that situation? And 3 radical 3 plus 3 radical 3 is 6 radical 3's. But see, we can't add these together because they're not like terms. These are radical 2's, these are radical 3's. Again, if this was 8x, this would be 8x, but this is like 3y, and this is 3y. If you treat a radical like it's a variable, you can totally add 8x and 8x and get 16x, and 3y and 3y is 6y, but you can't add x's and y's together. So you treat a radical like he's a variable in that situation. And then I want to approximate that. So 16 square roots of 2. Get out of that radical, either close your parentheses or hit the right arrow key, depending on what kind of calculator I have, plus 6 square roots of 3. And round that to the nearest tenth. That's going to be about 33.0. Remember, we do use the 0. Don't discriminate against 0. He's a number just like everybody else. And the label on that, since they don't give me one, is going to be units. And the area will be the length times the width. Area will be 8 square roots of 2. Put that in parentheses, times 3 square roots of 3. And multiplying radicals is a little different story. Just like multiplying variables you can take x's times y's, you can take radical 2's times radical 3's. So the way we roll with it is number times number is the way I like to do with it. That's this 8 and this 3. Number times number is going to give me a 24. And radical times radical, radical 2 times radical 3, it'll give you another radical back, but you just multiply those numbers and get yourself a 6 underneath there. So this is said out loud as 24 radical 6 or 24 square roots of 6. A lot of people don't know how to say it out loud right either. So 24 square roots of 6, which I will approximate that. 24 times the square root of 6 is about 58.8 units squared. So old school stuff that we know how to do with a new twist, doing all these radicals. All right, and then some story problems. The swimming pool is 22 feet wide by 36 feet long. Let's go ahead and put that information in the picture. Remember, if they give you a picture, they give you information. Let's put that. So this is the swimming pool here, though, in blue, because this thing outside of it is the fence that they're going to build here. So there's a privacy fence that's going to build around it. How much fence will be needed? So first, 22 feet and 36 feet. Sorry. Dang pen. And they're both in feet. And it's rectangular thanks to the picture. So this is going to be 22 and this is going to be 36 also. But they say they're going to build a fence around it 12 feet from the edges. Now, the trick to that is, like, here's the fence outlined around the outside. The trick to that is you got to go 12 feet away this way, and you got to go 12 feet away this way. Right? Because you got to go 12 feet on both sides of this dimension right here. So this entire distance right here is actually going to be 12 plus 36 plus 12. So that's 24 plus 36, which is 60 feet up here. Remember, we had to go 12 feet on both sides of the pool, and it's going to work very much the same way when we go this way. This is also 12 feet away from the pool, and this is also 12 feet away from the pool. So to find this entire distance right here, it's 12 plus 22 plus 12. So 24 plus 22 is 46 feet. Now they say how much fence is needed. You have to outsmart the problem and realize, okay, if you're going to put a fence around something, is that more of a perimeter or is that more of an area? And I hope, because we're advanced students, that we know that putting fence around something is the perimeter. So I need to do 46 plus 60 plus 46 plus 60, and realize that that is 212 feet of fence that we need. So if we were going to a hardware store or something, we know we'd have to buy 212 feet of fence to get around the outside of that pool. A satellite has been reported to fall out of the sky over this rectangular region of houses. So there must be houses inside of there, right there. So it's in this rectangular region. Billy has a circular swimming pool in his backyard with a radius of 15 feet. So that would be this, and it's got a radius of 15. So I'm going to put that information in my picture. What is the probability that the satellite lands in Billy's pool? And I didn't grab a highlighter there, sorry, but probability is what they were wanting us to find. Probability is a very simple thing to find. The way I define probability is what you want to have happen divided by the total possibilities. So I will abbreviate it as want over total anymore, but it's what you want to have happen divided by total possibilities. So what's the probability that the satellite lands in Billy's pool? So the satellite is going to land in an area. We totally need to find the area of these shapes. So we're going to go off to the side, and we've got the area of the circle. So area of the circle will be pi r squared, and the area of that circle, the radius is 15, so 15 squared, we should know that, is 225. And I'm going to keep it exact, 225 pi. I'm not going to approximate until we're all done. So always keep everything exact until we're ready to totally give our final answer. And the area of where the satellite is definitely going to land in, that shape is a rectangle because they told us so. Even though it doesn't have the four right angles, they say it's a rectangle. So area equals length times width, and that's going to be the area of the rect. And that's going to be 60 times 150. So 60 times 150 is 9,000. So we know that that satellite is guaranteed to land inside the rectangle somewhere, and it just so happens that that pool is inside the rectangle. So it's quite possible that that satellite could hit the pool, but they say geometrically, that's what this is geometric probability. We want it to land in the pool, so that is 225 pi for an area. That's how much space that takes up out of a total of 9,000. So there's our exact answer right there. We could reduce that down and do the 225 over 9,000, but I'm not so concerned about that. I want to do more of an approximate answer. So we're going to do 225 pi, and notice this, I'm going to put the 225 pi in parentheses because that numerator has like more than one term. So, and I want to divide that by 9,000. And I'm going to change this to a percent, to the nearest tenth of a percent. So remember, to change the percent, you got to move the decimal 2 places over, and that's about 7 point, it's either going to be 7.8 or 7.9. Since this is a 5, this has to be rounded up, so about a 7.9% chance of that happening right there. So we did geometric probability. We wanted it to land in the pool. This is the area of the pool. Total area of 9,000. So on 11 here, we've got ourselves a target. The target has 3 basic circles here. So what I'll do is I'll grab ye old highlighter, and we'll call this outside guy, he's basically like a big blue circle. And then inside of that, I've got this orange circle. And then inside of that, let's go with this green circle. So there's like 3 circles there in that situation. They say, first off, what is the area of each circle? So let's roll with it. I'll do the area. I'm not going to call it the blue circle because I don't have it highlighted, but we'll call it the area of the outside. So area of the out is pi r squared. Remember, we got to start with the formula. And its radius is 25, right? Because they tell us so. So area of the outside circle equals 25 squared. So if you don't know that, we can always punch that in. That would be 625 pi, and that would be inches squared. But we're going to keep that exact because that's all I really care about in this situation. Then we've got to do the area of that orange circle, which I'll have to do in red because I don't have an orange color here. So the area, I'm going to call that the middle. So the area of the middle is pi r squared, and that area of the middle is 14 squared times pi, so that would be 196 pi, and that would be in inches squared. And finally, the area of that green guy, which is the, let's just call it the area of the small, is pi r squared, and that would be 64 pi. So each little circle, you got the green guy, he's got 64 pi inches squared, and the red guy, aka the orange guy, and the outside guy. Well, what is the area of the shaded region? Well, to find the area of the shaded region, it's pretty cool. So you can see here that the target is made up of 3 different circles. You've got this giant outside circle right here, and then the inner circle, I could call it the middle circle actually, and then you've got the small inside circle right here. Well, they want us to find the area of the shaded region, which in this picture is pink in that situation. So to find the area of the shaded region, this guy doesn't matter one bit. So we can throw away the entire outside circle. It doesn't matter. But see, it's not just the area of the middle guy. We got to take away this situation here to where what we're actually looking at is we've got that same middle circle, and we have to subtract away the inside circle to where we have nothing left here but the ring. So we see that we got to take the area of the middle guy and take away the area of the inside guy. So I'm going to do 196 pi take away 64 pi, and see, these are like terms because they both have a pi with it. It's like 196x minus 64x. So all I have to do is totally just take those coefficients minus each other and realize that that's 132 pi. That's the area of the shaded. So let's kind of label that area of the shade equals 132, SH for shade. and that'd be inches squared. Well, they say, what is the probability that the dart will land in the shaded region if a dart is thrown at random? So they're back to probability again. And remember, probability is what we want to have happen divided by the total in that situation. So they want it to land in the shaded region, which we know the area of the shaded region is 132 pi. The total of that guy is going to be the entire blue circle, because that blue target right here, if you turn that around, this is how big it is. It's the entire thing right there. So that blue circle, we found his area also. That thing is 625 pi. And cool thing about keeping it exact is when you've got the same thing upstairs and downstairs in a fraction, like you got a pi over pi, it totally cancels each other out. So we got 132 divided by 625. We don't even need the pi's. So that is about, let's just keep that like exact since it came out so nice. This is nice and clean. So it's a 21, sorry, I want an equal sign, 21.12% chance, because we moved that decimal 2 places to the right, and since that's nice and clean, I didn't even round it off. So that's the probability that a dart that's like guaranteed to hit that. Now we all know that if you throw a dart, you might even miss the target altogether. So we're going to take an example, or take for granted is what I'm trying to say, that it's going to hit the actual circle itself, but the chances if it was just at random that you threw it and it landed in the shaded region is 21.12%. Cool. More probability. Give the probability that the spinner will land in region A. So we can see here, this is region A. Thank you, letter A. And remember probability, I like to do the W over T, what you want over total. We want to land in region A. Well, you notice they're giving me all these degrees of this circular spinner right here. Well, we want to land in region A, and that's 40 degrees. Out of the total target, you could add all of these up together, but I hope you know that in a circle there is 360 degrees total. And this is actually pretty simple to reduce because I can cancel them zeros right here, and you get 4 over 36, which is 2 over 18, which is 1 over 9 if you want to reduce that. And then we could divide that out. 1 divided by 9 is 0.1 repeating, so that's about 11.1% chance in that situation. So because you move that 2 places to the right and then round into the nearest tenth. So want over total. So Dave is running in this pattern below. So Dave's going to run from point A to point D. Good for Dave. If Dave trips at random, what is the probability that he will trip between points B and C? So boom, boom, between points B and C is right here. They want probability, so I'm going to do want over total. We want to know if Dave trips in region C. Well, that's 1250 feet divided by the total distance. So I got to add those together. So 2000 plus 1250 plus 2200. The total target is 5450. And we will punch that in. 1250 divided by 5450. And that is about a 22.9% chance that he trips randomly in that spot right there. And just one more of these bad boys, baby. Find the probability that a point chosen at random is in the shaded region. So you can see the outside shape is totally a circle, excuse me, totally a rectangle, and we've got circles inside of this. And here's what we need. We need to find the probability. So we got to do want over total, and we want to land in the shaded region. Well, the area of the shaded region is a goofy shape, right? So we have to figure out what that is. And wouldn't that be the rectangle, the whole big thing, take away these two circles? So I need the area of the rectangle. That's going to be length times width, and the area of the rectangle is going to be 12. I'll let you skip those steps when they're that simple. You know, it's 4 times 3 is 12. The area of the rectangle is that. But to find the area of the circle, what we want to notice is, like, I need the radius. So area of the circle is pi r squared, or I need a diameter so I could find the radius, you know. But They don't give me that. But what they do give me is this information right here. This whole distance is 4. So to find the area of these circles, I need a radius or a diameter. Now, the problem with this guy is they don't tell us that these two circles are congruent. We have to assume it. Sure, they look the same, but they don't tell us. But see, this distance right here is 4. This is definitely true that this distance right here is 4. And assuming that these two circles are the same, they're congruent to each other, that means that this guy is 2 and this guy is 2 for diameters of this bad boy, meaning the radius of each circle is 1 in that situation. So the area of the circle is going to be, like, let's just call it this circle, this blue circle right here is 1 squared, so it's just going to be pi. And like I said, if these circles are congruent, then this circle over here is going to be the same thing. So I have 2 of those guys, so the area of the shade is going to be the big guy, which is the rectangle, which is 12. Take away the 2 circles, so together they have an area of 2 pi. So I'm going to go ahead and punch that in, 12 minus 2 pi. Oops. 2 pi. And I'm going to keep that number in my calculator, but when I write this, I'm going to say that it's 12 minus 2 pi. That's the exact area over the total area, which was 12. Pen is not working very well. I apologize for that. So here's that number, 12 minus 2 pi. I should have not round it off. I'm just going to divide that by 12 and totally get about a 46.66% chance that point chosen at random is in the shaded region situation. So the area of the shade is 12 minus 2 pi, and we figured that out. We didn't round it because we don't round until we're done. Divided by 12. So cool, man. That's our lesson 2.5 on area, perimeter, circumference, geometric probability. Let us know if you have any questions, and have a good one.